Hello all, and welcome to, this is going to be your last week in Chapter 5, which means next week you're going to have your Chapter 5 test, so just want to give you that heads up. So we're going to do our other trig functions, tangent, secant, cosecant, cotangent for graphs today. So if you want to either print out these notes so that you have some axes to work on, or at least grab some graph paper, I would strongly recommend that you do that. So if you need to, pause this video and get yourself ready for notes, and we're going to get started. So when we're graphing our trig functions, we're just going to go through these without any different changes of period and amplitude to start with. So we're just going to do tangent, cotangent, secant, cosecant. But just like with sine and cosine, you are going to have changes of period, changes of amplitude, and in this case, you're going to add in a separate thing where you're going to mark asymptotes. So if we are looking at sine of x, and this is also true of cosine, secant, and cosecant, then your formula for period is 2 pi over k. And remember that k is the coefficient of the inner variable, and then 2 pi is like your basic period without any transformations. Now what's important here is that you'll notice if it's tangent, or in this case cotangent, the period is pi over k, and so you have just a smaller period for tangent and cotangent. Amplitude, again, is going to be your outer a term, if there's one right there. So your base for this is plus or minus 1. And I'll give you this note right now, is that doesn't matter for tangent and cotangent. It absolutely does matter for secant and cosecant, so we'll talk about that. But it doesn't really matter for tangent and cotangent. Now, your third thing that you're going to have is you're going to have asymptotes. Now, these are going to be vertical asymptotes. And if you remember that, that's where the denominator of a function is equal to 0. So now, if you remember, tangent is equal to sine over cosine. And the other function that's over cosine is secant. And that's 1 over cosine. So these functions have vertical tangents. They have asymptotes at wherever cosine of x is equal to 0, right? And if you think about what those functions, what those places would be, is that it's anything pi over 2. So if it's pi over 2, it's going to have, and these are your base graphs, you're going to have vertical asymptotes there. The functions that are over sine are cotangent and cosecant. So this is cotangent is cosine over sine. Cosecant is 1 over sine. And these will have asymptotes wherever sine is equal to 0. And for the base ones, that's going to be where any multiple of pi. So, like I said, this is how I'm going to draw them in. So here, for tangent of x, we're going to mark the period in. I'm still going to mark 2 pi. We're just going to have 2 waves. That's fine. So pi is 1 period. Divide by 4, just like we would before. And, you give yourself a little negative pi over 2, because this is going to be helpful. So pi over 2, 3 pi over 2. You can mark the asymptotes, as I said, you can mark the y-axis amplitude. It doesn't really matter with tangent. So the next thing you're going to do is mark the asymptotes. Now, since it's tangent, it's wherever cosine would equal 0, which is your pi over 2's. So you've got negative pi over 2, pi over 2, and yes, all of these are going to have a lot of asymptotes. So there'd be another one here if you kept going, and so on. So in between each of these sections, if it's tangent and cotangent, you're going to have a root. So tangent has a root at all these terms pi, which would make sense. So because it's root at wherever the numerator is equal to 0, since it's over sine. And what this is going to be, it's going to have this vertical asymptote, and just go swoop up like this. You'll have another one here, and it's basically just a copied, instead of a single wave, there are these infinite waves going along as you go along the x-axis here. Cotangent's going to work out really similarly. I'm going to do 2 pi divide. As I said, you can mark the amplitude, but it is only going to matter for secant and cosecant in this lesson. Then I'm going to mark the asymptotes. For cotangent, it's where sine is equal to 0, so it's where all the pi ones are. So 0 pi, pi, 2 pi. So you'll notice they're sort of like inverses of each other. They are reciprocals, remember, tangent and cotangent. And so then the roots are at the remaining points. So these have the roots at wherever cosine is equal to 0, because that's the numerator here. So again, nice reciprocal action. And here the graph is going to go similar shape but downward. So we're going like that, and then it's going to keep repeating. Obviously there'd be more if we kept drawing this. We kept drawing like that. So similar shapes, just the reciprocals of each other. So if you can remember one, you can reverse engineer and remind yourself of the other. So those are your tangent and cotangent. So using this same logic here, we're going to look at secant and cosecant. So secant, it's really helpful to remember. Secant of x is the same as 1 over cosine of x. So start 2 pi, divide by 4. Now here you do have to mark the amplitude. And if we think about what the graph of cosine looks like, I'm going to sketch that in really lightly in green right now. Cosine starts at the top, comes down, comes back up, would keep going, would keep going. So whenever it's 0, this is where I'm marking in my asymptotes, right? Because that's where the denominator equals 0 at pi over 2 and at 3 pi over 2. So those are our asymptotes. The other points that are always going to be the same are here. So you're going to have, just like you would if you were graphing cosine, you're starting the same way. You're just drawing in those asymptotes, and it's the reciprocal. So here we've got a lovely little curve like this. The reciprocal just goes the other way. And since it's got those asymptotes, it goes forever in that direction. So again, here we have a little curve like a smiley face. Reciprocal is the frown, and then we'd have one here, and these would keep repeating in this pattern forever. You want to clean it up, you can erase that dotted green line, but I'd fine just with you leaving that in. Cosecant is similar logic. If you remember, cosecant of x is 1 over sine. So I'm going to start the exact same way as I would with sine. Mark the amplitude, 2 pi, divide by 4. And in this case, I'm going to mark my asymptotes here at 0, pi, and 2 pi. And remember, the graph of sine has the roots and then goes up and down. So graph of sine would look like this. Therefore, it's reciprocal. Still goes through those points. But here we have our facing down frown. So this becomes up, down. If we had another one here, be like that. If we had one over here, and so on. So again, just like how sine and cosine are really the same shape, just scooted over, same here, secant and cosecant the same shape, just scooted back and forth. So let me know if you have questions about any of these graphs or about using their amplitude changes and amplitude changes in period. But remember, the rules are going to be the same as they were for sine and cosine from last week.